Let's start this problem by looking for chiral centers. What we want to look for a chiral center is an atom that has 4 different groups attached. So halogens certainly aren't going to be chiral centers. A CH3 group has 3 hydrogen. That's not going to be a chiral center. Alkenes are never chiral centers. And the only other atom we have left is the CH2, and since there's 2 hydrogen on that carbon, it's not a chiral center. So this molecule has 0 chiral centers. Now we want to look for how many stereocenters it has. A stereocenter is a more broad category than chiral centers, and this is an atom at which the interchange of 2 groups produces a stereoisomer. And alkene carbons can often be stereocenters. Here we have 4 alkene carbons. And let's just look at one of these and see what happens if we interconvert 2 groups. So on this far left alkene carbon, I'm going to go ahead and draw in the hydrogen. Now, if we take the H and the Br and swap those 2 groups, let's do that. And we'll draw what we get from doing this. Right, remembering that the double bond locks things in place, I have a pair of molecules that are non-superimposable and they're not mirror images. Now don't get confused and think they're constitutional isomers. These are not constitutional isomers because they have the same atom connectivity. You start with a Br, that's bonded to the alkene. Then CH2, the alkene, and the methyl. CH2, alkene, and methyl. The bonding is the same. The only difference is 3-dimensionally, the H and the Br are in different positions. So swapping those 2 atoms of that carbon gives us a stereoisomer. In fact, this is a diastereomer. So that makes this a stereocenter. Likewise, if you were to do the same thing at this carbon and switch the hydrogen and this large chain, that would also give you a stereoisomer, so that's a stereocenter. And the same is true for these 2. So this molecule has 4 stereocenters. Now, for this one, I would also accept 2, and if you were doing that, that would be considering the alkene as an entire stereogenic unit. So when is an alkene not a stereocenter? Basically, you run into that when you have 2 of the same group on one side of the alkene. So for example, here I have 2 hydrogen. Or even if I had 2 ethyl groups. Now this alkene is no longer a stereocenter. Neither carbon of the alkene would be stereocenters because if you switch the 2 groups at either carbon, you end up with an identical molecule.